Hello everyone, welcome to Daily Network Visuals channel. Today we are going to talk about how one host reaches another through a switch. Consider that there are three hosts all plugged into one switch. Host A wants to send data to host B. Sounds simple, but host A has a problem to solve. The switch hasn't learned anything yet, and A doesn't know B's MAC address. Also, consider that all these three hosts are in same VLAN, which means they are all part of one broadcast domain, and they all have the same subnet. So, B is local. A can reach it directly. To put a frame on a wire, A needs B's MAC address. So, A broadcasts an ARP request shouting to the whole VLAN who has 10.0.0.2. Inside the request, the Ethernet destination is all Fs, which means it's broadcast. Opcode is set to 1, which signifies ARP request. Target IP is set to host B's IP address, and target MAC is all 0 because that's what A is trying to find. The switch receives it on port 1. Switch learns A is on port 1, and then switch floods the request out every other port, that is to B and C. Host C checks the target IP, not mine, and drops it. But how about B? That's its own IP address. So B answers. B sends an ARP reply, not a broadcast this time, it's an unicast, straight back to A. Inside the ARP reply, opcode is 2, and destination MAC address is set to A's MAC, and B fills in its own IP and MAC as the sender. Switch learns B is on port 2 and forwards the reply only to A, no flooding this time. A finally has B's MAC address and it saves it in its ARP cache, so no need to ask again. Now the data flows. The switch sees B's on port 2 and forward the frame only there. Host C never sees it. If you look at the data frame, the destination is B's MAC address. Ether type is set to 0x0800 for IPv4, carrying IP packet from host A to host B. That's the whole story. ARP found the MAC, switch learned the ports, and A and B talk directly. Please subscribe, like, and follow for more network content.